Nano Nuclear Energy, or just NNE, is an emerging pre-revenue nuclear energy company that quickly became famous for its development of smaller, cheaper, and safer nuclear reactors that are portable, as well as their comprehensive approach to be integrated across every sector of the nuclear power industry, ranging from commercial nuclear fuel transportation to consulting services. They have a stated focus on developing next-generation advanced nuclear microreactors Zeus and Odin, advancing the portable, on-demand capable, advanced nuclear microreactors, collaborating with U.S. national nuclear laboratories and government support, and aiming to commercially launch one of these products by 2030 or 2031. Both Zeus and Odin have moved from design stages to physical test work stages, with initial rig construction currently underway. They've completed external design audits on both reactors conducted and completed by the Idaho National Laboratory, INL. NNE is identifying sites for their prototype reactor to conduct physical test work using nuclear material for both microreactors and has communicated with the U.S. Nuclear Regulatory Commission, NRC, and Department of Energy, DOE, regarding the status of their microreactor designs and estimated internal timelines for their microreactor developments. The acquisition of a building in Oak Ridge, Tennessee, is going to serve as their nuclear technology headquarters. Dr. Michael Narado, an experienced professional with ties to INL and DOE, was appointed Director of Nuclear Facilities and Infrastructure in December 2024. His role includes overseeing construction, development, and licensing of key facilities related to the Zeus and Odin microreactor projects, as well as establishing deconversion and fuel processing facilities. Over the next year, they plan to increase staff at the facility to around 30 people and invest approximately $800,000 in renovations. In December 2024, the company signed a memorandum of understanding with the Idaho Operations Office of DOE about collaborating on constructing a demonstration reactor near INL. Work also continues on developing a domestic LEU and HALEU fuel supply chain through their subsidiary HALEU Energy Fuel Inc., collaborating with the DOE. To this end, a $2 million investment in LIS Technologies enables them to help advance their uranium enrichment technology. This collaboration could provide enriched uranium hexafluoride for fabrication and sale, while compensation would be shared between the companies. The company has also been selected by the DOE as one of 6 awardees under the Low-Enriched Uranium Enrichment Acquisition Program, which will involve collaboration with LIS Technologies. The fuel transportation business segment is still looking to utilize an exclusive license for a high-capacity HALEU, high-assay low-enriched uranium, transportation basket design obtained in April 2024. NNE aims to develop a complete transportation system, positioning itself to provide services not only for their reactors, but also to other nuclear companies. An agreement with GNS Gesellschaft für Nuclear Service MBH is meant to help with optimizing the transport of various HALEU fuel types and developing a conceptual package design accommodating the new basket technology. The company aims to obtain NRC certification for its transportation system by 2026. 2 former UPS executives have been brought on board to help grow this transportation business. Plans to provide nuclear service support and consultation services for the growing nuclear energy industry, both domestically and internationally, are set to begin in 2025. They aim to offer services like regulatory advice, site assessment, roadmap development, stakeholder engagement, and more. They're exploring strategic acquisitions as well as working on building the internal nuclear consultation business in collaboration with certain academic institutions, which would require a budget of about $2 million over the span of 2025 for staff recruitment and infrastructure development. In this area, NNE entered into non-binding memorandums of understanding with DigiHost Technology, Inc. to provide consulting services for their 60-megawatt power plant in New York, as well as a joint response submission to the NYSERDA's RFI on advanced nuclear energy technologies. Now let's delve into more detail on plans around the reactors. Nano Nuclear's portable nuclear microreactors. Zeus is a solid core battery reactor that uses already licensed fuel types and has no coolant, making it safer than traditional reactors. Whereas the low-pressure coolant reactor Odin utilizes uranium and zirconium HALEU hydride. The reactor design aims to improve reliability and service life by using low-pressure solar salt coolant and taking advantage of natural convection for heat transfer. A nitrogen or open-air Brayton cycle will be used for power conversion due to its simplicity and wide use in the conventional power industry. Reactivity control system design will have high reliability through minimizing moving parts. The company plans to engage with the NRC and complete salt irradiation testing by 2025, selecting the coolant for Odin and developing a Regulatory Engagement Plan, REP. NNE outlines sectors and uses for their portable reactors like data centers, military applications, disaster relief, transportation, mining projects, water desalination, green hydrogen plants, and space exploration. Both reactors have completed design audits and are set for demonstration work starting in early 2025, initially with Odin followed by Zeus. The company plans to file for new patents relating to Zeus in 2025 and work on advancing this technology with the help of the INL's GAIN program. They aim to have working prototypes ready by 2026 to 2027 and anticipate regulatory licensing to be completed by 2030 or 2031, allowing them to deploy microreactors across the country upon approval. The company has also signed a memorandum of understanding with the Idaho Operations Office of the DOE for potential collaboration in siting, constructing, commissioning, operating, and decommissioning their microreactors at INL. Additionally, Dr. Michael Naranjo was appointed as Director of Nuclear Facilities and Infrastructure to oversee construction, development, and licensing of key facilities, including the company's newly acquired Oak Ridge, Tennessee Nuclear Technology Headquarters, and future testbed reactor sites. Earlier, a subsidiary called HALEU Energy Fuel Inc. was established. It focuses on creating a domestic fuel processing facility for low-enriched uranium, LEU, and high-assay low-enrichment uranium, HALEU. They have been selected as a founding member of the DOE's new HALEU consortium, aiming to develop U.S. capabilities in manufacturing HALEU and its processing. Their strategic goal is to design, construct, and commission a commercial nuclear fuel processing facility supplying fabricated fuel to advanced nuclear reactor companies, including their own reactors under development. The company plans to work with the NRC through the NEPA process for the proposed project and has entered into a partnership agreement with an enrichment company called LIST. They've also been selected by the DOE to participate in the LEU acquisition program as one of 6 contract awardees, where they will bring their technical and regulatory expertise in advanced nuclear solutions to the collaboration. Attention is also focused on fuel transportation for emerging small modular reactor, SMR, and microreactor companies, as well as government programs and potential military applications. The company has licensed technology from INL and ORNL to create an 18-canister inner basket design with a borated aluminum flux trap for high-capacity HALEU transportation. They've also entered into agreements with Battelle Energy Alliance, BEA, and GNS to further develop their transportation system solution, which includes the optimization of multiple HALEU nuclear fuel types and conceptual package designs. The business aims to form the first transportation company capable of supplying all emerging SMRs and microreactor companies with the fuel they need at their manufacturing facilities. On April 3, 2024, the company entered into a BEA license with Battelle Energy Alliance for a U.S. patent related to devices and systems used for HALEU transportation. This license grants the company exclusive rights for worldwide use within the specified scope, obligating royalty payments on net worldwide sales and certain licensing payments. The agreement has specific performance milestones for HALEU fuel transportation, an indefinite term until the expiration or termination of the licensed patent. Both parties have included customary representations, warranties, and indemnifications in the BEA license. Although NNE's plans are highly ambitious and expensive, they can lean on support driven by growing interest and investment in nuclear energy within the United States. The government has set targets for reducing greenhouse gas pollution and achieving net zero emissions by 2050, while utility companies aim to incorporate more nuclear power into their decarbonization plans. This push for growth in the nuclear sector is also supported financially through government allocation and investments from major tech companies. However, NNE tries to differentiate themselves by not being reliant on government funding for their operations, having an investor base consisting of capital raised from nuclear industry professionals, and possessing technical insight into potential problems affecting the industry. The company has also recruited individuals with high-placed government service and contacts, as well as a technical team that does not require exotic fuels and has incorporated applicable regulatory considerations in their reactor designs since the outset. When looking at U.S. government initiatives, we're talking about policies related to things like the ADVANCE Act, advanced reactor development programs like ARDP and ARC, the Nuclear Energy Innovation and Modernization Act, NEMA, loan guarantees, nuclear energy research and development funding, public-private partnerships, support for existing nuclear fleets, promoting nuclear energy exports, and significant budget allocations to the Department of Energy's Office of Nuclear Energy and other related programs. Another way Nano Nuclear intends to differentiate itself is by becoming a vertically integrated business, with multiple revenue streams and a diversified model that can adapt to market changes. They're developing reactors within the 1 to 1.5 megawatt electric power output range, which is currently an undeveloped commercial space. In addition, they have an advantage in recruiting top talent from around the world, having connections with renowned professors and scientists globally. An advantage they intend to grow through initiatives like the partnership with Cambridge Nuclear Energy Center to develop nuclear teaching programs for master's and doctorate degrees in related disciplines like science, physics, and engineering. The aim is to educate qualified individuals to meet the growing demand for nuclear personnel while also providing practical learning applicable to the current nuclear industry. This strategy will help source competent staff for their reactor programs, fuel processing business, and services practice while offering attractive job opportunities within the nuclear energy space to the graduates. On the flip side, there are immense and unique challenges from being a young company in the nuclear energy business, with hurdles ranging from obtaining permits and licenses for reactors and facilities to meeting stringent safety and environmental standards, as well as ensuring robust security measures and managing capital-intensive operations. All while navigating the political and regulatory landscape, the company must overcome these hurdles to secure funding, maintain cost-effectiveness, and ensure the viability of their nuclear projects. On a somewhat related note, Nano Nuclear's insurance coverage includes director and officer liability insurance, but does not cover keyman life insurance, business liability, professional liability, property insurance, or business interruption insurance. Despite potential risks from product liability or professional liability claims, they deem their current insurance sufficient due to their developmental stage and lack of products. Then there's direct and indirect competition in the broad power generation industry. The competitors include fossil fuel power generating units, renewables, long-duration storage, and other nuclear reactors, including microreactors. However, the company believes they have an edge over their competitors due to their carbon-free round-the-clock energy generation capabilities. NNE asserts traditional energy sources such as oil, coal, and natural gas are largely being replaced by carbon-free energy sources like wind and solar power. The company's innovative design of SMRs and microreactors allows them to operate as baseload generation, load-follow renewables, or support key industrial applications. Other advanced nuclear reactors are in various stages of development, but have not received regulatory approval in the United States, nor have the necessary fuel supply infrastructure to succeed. Now let's get up to speed on some ongoing progress concerning deals, intellectual property, and partnerships. Meaning we'll go back to June 21, 2024, when NNE acquired the intellectual property for a novel annular linear induction pump, ALIP technology, used in small nuclear reactor cooling from Carlos O. Maidana, PhD, and his research firm, Maidana Research. Dr. Maidana has also agreed to collaborate with the company on further ALIP tech development, aiming for an SBIR Phase 3 award status. The acquired ALIP tech is a key enabler for their Odin microreactor in development and has potential for separate commercialization within a year. The company issued 50,000 shares of common stock and paid $50,000 to Dr. Maidana, with promises of additional shares and cash if the SBIR Phase 3 project is completed successfully by June 21, 2025. Further intellectual property progress relates to filing for U.S. provisional patents for their Zeus design and acquired annual linear induction pump technology. The company has opted to maintain other technologies as trade secrets, but is consulting with legal counsel on patenting aspects. They plan to file utility or design patents for Zeus and Odin microreactors before March 27, 2025. They believe comprehensive development before patenting offers strategic advantages such as stronger claims and reduced risk of invalidity, while also considering the potential delays in securing protection. The company has one trademark application, pending approval, and one domain name. Then, on December 18, 2024, the company entered into an agreement with USNC to acquire select nuclear energy tech assets, which include USNC's micromodular nuclear reactor business, MMR Energy System, and Transportable Fission Power System Technology business, Pylon Transportable Reactor Platform. The MMR Energy System is a zero-carbon nuclear power plant that integrates one or more standardized microreactors with a heat storage unit and adjacent plant for power conversion and utilization. It can provide carbon-free, high-quality process heat and high-efficiency hydrogen production. The system complements the company's Zeus and Odin microreactors in development. In contrast to Zeus and Odin, the MMR energy system is stationary and designed to produce up to 45 MWth of power. The pylon reactor is versatile for various applications and deployments, providing between 1 MWth and 5 MWth of power. It can be integrated with modular balance of plants tailored for specific uses, including remote terrestrial, marine, and space deployments. Going back to the partnership project with INL, Idaho National Laboratory, it involves an expert review panel for their Zeus microreactor design. They've also been awarded 200 hours of subject matter expert support at INL as part of the National Reactor Innovation Center Resource Team program. The work focuses on delivering a thermal hydraulics model, Monte Carlo model, and optimized version of the reactor core, including thermal hydraulics and neutronics. In general, research and development regarding Zeus and Odin technology focuses on optimizing reactor dimensions, material compositions, simplifying mechanical systems, lowering life cycle costs of microreactors, and developing new technologies for future business endeavors like fuel processing and transportation. Next, let's go over some memorandums of understanding, since Nano Nuclear has entered into quite a few of them. First is a services agreement between Nano Nuclear Energy Inc. and Cambridge Atom Works, where Cambridge Atom Works assists in the development of Nano's Odin microreactor. Another memorandum of understanding is between HALU Energy, a subsidiary, and Centrus, for the potential supply of high-assay, low-enriched uranium to support research and commercialization efforts. On top of that, there's a strategic partnership project agreement between Nano Nuclear Energy Inc. and BEA, which involves an expert design panel reviewing and providing recommendations for the Zeus microreactor design. Other agreements and collaborations go back even further to January 2024, such as a services agreement with Nuclear Education and Engineering Consulting LLC, NEEC, to support the design and development of a solid-core nuclear reactor. Then in July 2024, NNE signed a Memorandum of Understanding with Everstar Inc. to explore using their AI-driven advisory solutions for modernizing regulatory licensing processes. Similarly, in August 2024, they signed an MOU with the Rwanda Atomic Energy Board to introduce and integrate small modular reactors, SMRs, and microreactors in Rwanda, including providing technical assistance and educational programs. In November 2024, they signed another MOU with Vert2Grow Energy Solutions to explore integrating their portable microreactor technology with vertical farming solutions for sustainable power and food production worldwide. Other international developments involve the government of the Togolese Republic that aims to collaborate on developing and deploying nuclear reactors, fuel facilities, and nuclear material transportation within Togo's territory. This collaboration will bring advanced nuclear technologies like microreactors to support remote energy needs across industries in the country, without connecting to the national grid. Domestically, DigiHost plans to transition the company's 60-megawatt power plant in upstate New York to carbon-free energy using NNE's technology. This collaboration will provide clean, reliable energy for DigiHost's high-tech operations and aid in optimizing their existing gas-powered infrastructure while planning for future nuclear deployment. On the topic of government regulation and safety measures pertaining to the commercial use of nuclear technology, specifically relating to the design, construction, and operation of microreactors, safety regulators primarily consider the safety and robustness of designs against internal and external hazards as well as environmental impacts. The licensing strategy for these microreactors includes obtaining regulatory approval through efficient pathways and maintaining a standard design in multiple markets by pursuing NRC standard design certification. Other regulations to consider relate to nuclear material safeguards, non-proliferation restrictions, liability insurance regimes, export controls, and the necessary permits or licenses required at different jurisdictional levels. In regards to the regulatory approvals and requirements for the proposed HALEU fuel processing facility in the United States, as well as their plans for fuel transportation within the country and internationally, the company must obtain approval from the Nuclear Regulatory Commission, NRC, through the NEPA process for their facility design and safety systems. They plan to use proven technology and processes in order to minimize review time by the NRC. For fuel transportation, they will utilize NRC-certified transportation packages that meet DOT regulatory requirements within the U.S. and follow IAEA regulations for international transport. The company also acknowledges other nuclear regulatory controls, such as special nuclear material safeguards and non-proliferation restrictions, as well as potential state and federal permits needed depending on the facility's location and waste production. Lastly, they recognize export control considerations under NRC's authority in 10 CFR Part 110 and must apply for specific licenses to export special nuclear material. So while there will be plenty of progress that still needs to be made, NNE has a defined plan and support from the broader nuclear renaissance. For more on Nano Nuclear and other companies, follow Ascencore. Thanks for watching and have a nice day.